Question 2. A scientist measures the depth of the Doe River at Picnic Point. The river is 24 feet wide at this location. The measurements are taken in a straight line perpendicular to the edge of the river. The data are shown in the table above. The velocity of the water at Picnic Point in feet per minute is modeled by V of t, which equals 16 plus 2 sine of the square root of t plus 10 for 0 to 120 minutes. Part A. Use a trapezoidal sum with 4 subdivisions indicated by the data in the table to approximate the area of the cross-section of the river at Picnic Point in square feet. Show the computation that leads to your answers. So I did a quick sketch of our picture of our data points because I think it helps when it starts doing Riemann sums. So we're supposed to use trapezoidal, and it said to use the table to dictate our intervals. So we're going to have uneven intervals. That means we have to do each trapezoid separate. So here's my first trapezoid. It's actually just a triangle. Here's my second trapezoid. Here's my third trapezoid. And here's my fourth trapezoid. So trapezoid formula, 1/2 height, base 1 plus base 2 is what we're using. So we're going to find our area by doing 1/2. Our first interval is 8. A height between our two bases of 8. 1 is 0 for our base. The other base is 7. Plus our second trapezoid has a difference of 6. One base is 7, the other base is 8. Our third trapezoid is going from 14 to 22, so that's a height of 8. Our bases are 8 and 2, and our final trapezoid is a width of 2, and our height's 2 plus 0. So that gives me 4 times 7 is 28, 3 times 15 is 45, plus 4 times 10 is 40, plus 1 times 2 is 2. And we are getting 115 square feet. That's the area of the cross sections. Part B, the volumetric flow at a location along the river is the product of the cross-sectional area, so that's what we did in Part A, and the velocity of the water at that location. That was what we were given as V of t in our question. Use your approximation from Part A to estimate the average value of volumetric flow at Picnic Point in cubic feet per minute from 0 to 120. So I underlined a couple things. Product of the cross-section area, which we found in A, and the velocity, which we were given, and average value. So I'm going to use my average value formula, 1 over 120, 0 to 120. I'm going to use the product of Part A, 115, and the V of t that we were given in the question. Now we can use our calculator, so you could type this as is into the calculator with your V of t formula, and what you get is 1,807.170 cubic feet per minute. Question C. The scientists proposed the function f given by f of x equals 8 sine pi x over 24 as a model for the depth of the water in feet at Picnic Point x feet from the river's edge. Find the area of the cross sections of the river at Picnic Point based on this model. So this is an alternative to the data that we were given. We want to find the area based on the width of our river is 24. So I'm going to do the integral from 0 to 24 of f of x, so 8 sine pi x over 24 dx. Those pieces all added up, all of those different areas added up will give us our cross-section area, and we get 122.231 square feet. I just used my calculator for that value. Now we did the same thing in part A, and we got 115. So part A was an approximation using the data in our chart. Part C is using a model. Part D. Recall that the volumetric flow is the product of the cross-sectional area and the velocity of the water at the location. To prevent flooding, water must be diverted if the average value of volumetric flow at Picnic Point exceeds 2,100 cubic feet per minute for a 20-minute period. Using your answer from part C, find the average value of the volumetric flow during the time interval 40 to 60 minutes. Does this value indicate that the water must be diverted? So we're doing average value again. So we're going to do an integral. It'd be 1 over 20. The difference between 60 and 40 is 20. We're going to do our bounds of 40 to 60. We're going to use our value 122.23 as our cross-sectional area from part C. And then we're going to use our velocity function that we were given in the question, v of t dt. And when we do this, type it into your calculator, you get 2,181.913. And this is cubic feet per minute. So we were told in the question that if this volumetric average pressure or average volumetric flow exceeds 2,100 cubic feet per minute, then the water needs to start being diverted to prevent flooding. So the question is, does this value indicate water must be diverted? And the answer is yes. Our volumetric flow here is greater than 2,100, so water must be diverted.